Hello, I'm Graham Lewis, and in this video we're going to discuss the function x divided by x minus 1 over x minus 2, and we're going to think, how many restrictions does this have? And we're going to have two friends to help us. Hello, I'm Graham, and I'm going to argue that this function has two restrictions, one in the numerator of x minus 1, so 1x not equal to 1, and one in the denominator of that fraction, so x not equal to 2. Hey up, I'm Graham. I'm going to show you that this function has only one discontinuity, and that's in the numerator of the second fraction, x does not equal 1. Well, thank you, Graham. And thank you, Graham. Let the debate begin. Thank you very much, Graham. So my argument is very simple. Basically, if we look at here this second fraction, we can see that we cannot put in the denominator 2. Because if we put in the denominator the value of 2, then that fraction will be undefined. So straight away we can see that x cannot equal 2. Also, if we look at the numerator of this fraction here, we can see that overall we're dividing by a number. And clearly we can't divide by 0. So we can't divide by the number 0. So when is x minus 1 over x minus 2 equal to 0? And that's when x is equal to 1. So clearly x cannot equal to 1 as well. So without a shadow of a doubt, we can see that we have two restrictions, x not equal to 2 and x not equal to 1. Just in case you're not convinced, let's think of some numbers. Imagine I have 6 divided by 1/3. We know the answer is equal to 18. We know that because division is like repetitive addition, because it's the opposite of multiplication, which is repetitive addition. So how many times do I have to add a third together to get to the value of 6? And of course it's 18 times. So what we're saying is a third repetitively added 18 times makes the number 6. Now let's consider, and I shouldn't really write this down, let's consider making that 1 a 0. Clearly now we're saying 6 divided by 0 over 3. Well, 6 divided by 0 over 3 is 6 divided by 0. So we're saying how many times repetitively can we add 0 to get to 6? And of course we would go on for an infinite number of times. So clearly our numerator there cannot equal 0. It's undefined, giving us the x not equal to 1. Equally, if we look at the denominator there equal to 0, so if I keep the 1 and make a 0 there, we can see that this fraction now is undefined. So we don't have a number anyway. So 6 divided by an undefined is undefined. And hopefully I've convinced you categorically that this function does in fact have two restrictions, x not equal to 2 and x not equal to 1. Over to you, Graham. Hey up. Right, thanks for that, Graham. Now I'm going to show you unequivocally that y tan x equals sin x over cos x has exactly the restrictions that I require. And then I'm going to think of cot x and show you that that rational function does actually have only one restriction. So let's look at tan x first. So if we have a look at tan x, we can see we've got some restrictions when the denominator is equal to 0. Clearly when cos x equals 0, sin x over cos x would be undefined. So tan x would be undefined. So those are the values pi over 2, 3 pi over 2, etc., giving us vertical asymptotes. So we can see for tan x that we've got some restrictions there. Now let's consider cot x. Well, the argument's very simple. Cot x is defined to be the reciprocal of tan x, so that's 1 divided by tan x. And we know that tan x is sin x over cos x. So therefore, we know that cot x is 1 divided by sin x over cos x. And let's just have a look at this here. My argument is that the only restrictions here are in this numerator, sin x. So when sin x equal to 0, at pi, at 2 pi, at 3 pi, etc., when's cos x equal to 0? Well, obviously that's at pi over 2, 3 pi over 2, etc., 5 pi over 2. And those are actually the roots of cot x. Whereas in your argument, Graham, they would actually be now removable discontinuities wholes. But cot x does not have removable discontinuities at pi over 2, 3 pi over 2, 5 pi over 2. It has x-intercepts, or roots. So therefore, my argument is that cot x, which is 1 divided by sin x over cos x, is identical to the function, so 1 divided by sin x over cos x is identical to 1 multiplied by cos x over sin x, which is cot x. So therefore, looking at your function f, which is x divided by x minus 1 over x minus 2, the same argument, that is in fact identical to x multiplied by x minus 2 over x minus 1, giving you only one restriction in the numerator here, x minus 1, and the denominator here, so x not equal to 1. So only one restriction. Well, thank you very much, Graham, for that argument, and thank you very much, Graham, for your argument. Now, the important thing is, what do you think? Thank you for watching my video. If you enjoyed it, please watch some others, and have a great day.